Hello students, and welcome to the second half of lesson 7. So, I'm going to go through a few more examples with you about solving simultaneous equations. Now, what makes these ones a little bit different is the only instruction we're given for this question is to solve the simultaneous equations y equals 5x plus 2 and y equals 2x take 3 graphically. So that means we have to draw these completely from scratch. So our equation is over here. It says y is equal to 5x plus 2. Now, I've highlighted the 5 here because remember, this is our gradient. This is our slope. So you can see here I've written m equals 5 over 1. Remember guys, this means the gradient goes up 5 for every 1 it goes across. It's its rise, 5, over its run of 1. And obviously the y-intercept is 2. We can tell that from the equation. Apologies, by the way, for this weird blue line in the middle. That is due to the photocopier being annoying when it's scanned. I know, it bugs me too, but look, you're just going to have to deal. Anyway, the other equation, y equals 2x plus, y equals 2x take 3, 2 is our gradient for this one. So that means, with a gradient of 2, for every 1 it goes across, it goes up 2. And the y-intercept for this one is negative 3. So how do we draw these? Well, let's look at this one up here, y equals 5x plus 2. I would start with the y-intercept. Put a dot at the number 2. It says the gradient is 5, so therefore this line, for every 1 across, it goes up 5. So from the point 2, I'm going to go across 1 and then up 1, 2, 3, 4, 5 and draw another point. Once I have 2 points, all I need is a ruler. Sorry guys, I can't lend you a ruler for today's lesson. And connect those 2 dots as I've done here. Same process for the second equation. Y equals 2x take 3. So my y-intercept is negative 3 down here. The gradient for this one is 2. So for every 1 it goes across, it goes up 2. So across 1, across 1 and up 2. There's my second dot right there. I connect those 2 dots using my ruler, and where those 2 lines meet is my point of intersection here. So looking at the graph, the point of intersection is negative 1.5, negative 6.5. You'll note I've written the word approximately here. It's sometimes a little bit hard to eyeball from a graph. Students, it should be pretty obvious what the answer is, but if you're unsure, just take your best guess and we will factor that in when marking. So, looking at the second example, solve the pair of simultaneous equations graphically. So I'm going to go through A and E with you here today. So A is pretty easy. It says y equals negative 2 and y equals 2x take 4. So like with the first one, the first example I went through, the gradient is 2. So that means it goes up 2 and across 1. And the y-intercept is negative 4. I can determine all of that just by looking at the equation. So that first line, I plot my y-intercept, negative 4. Let's zoom in a little bit, shall we? Whoops, that's not the zoom function. Let's try that again. Okay, this isn't, oh no, there we go. Whoa, that's too big. Okay, there we go. So students, my y-intercept is negative 4 down here. And as the line says, the gradient is 2. So for every 1 across, it goes up 2. So starting at negative 4, 1 across, 2 up. Draw my 2 dots, connect the line. Now the other equation here is y equals negative 2. That means that every single point on that is going to be negative 2. It's just a flat line that looks like this. That's y equals negative 2. So when I look carefully at this, I can see that right here is my point of intersection, 1, negative 2. Making sure to write that and make it clear that the point of intersection is 1, negative 2. Make sure you have a statement in your solutions saying what the answer is. E over here is a little bit trickier because neither of them are in the form y equals, which makes it nice and easy to graph. So I'm going to have to rearrange. For E, I started by moving y to the other side. So x equals y. I could have moved x over as well, but it's easy to move y over. So x equals y basically just means the line is going to look like this. It's got a gradient of 1 and it goes through the origin. Another way to think of this line is it's y equals x. That's this line here. The other one, 2y plus x equals 0. Again, I need it in the form y equals so I can determine the gradient and slope straight away. So the first thing I did, well, I moved negative x over this side. Then I divided by 2 to move the 2 over. Then I finally got my gradient. It's negative x over 2, or negative a half. Dividing something by negative 2, it's like multiplying by negative a half. In fact, it's not just like that, it is multiplying by negative a half. Anyway, the point is our gradient here is negative a half. This means it goes down by 1 for every time it goes across 2. So, and also we don't have an intercept, so c is 0. So I start here and then I'm going down 1 and across 2. So I move down 1 and across 2 to get to this point here. Then I connect the 2 dots, and where's my intersection? Right in the middle of the Cartesian plane here, 0, 0, also known as the origin. Anyway, students, that's the end of the second round of examples for today's lesson. For the remainder of today's lesson, you know what to do. Head over to OneNote, look at what questions you need to do. If you have any questions, please post them in the collaboration space. Good luck.